This is the final project for microprocessors course, EEL 4744. I am representing the work of Sascha Heinzel, Anthony Bristow, and myself, Timothy Nassar. Here we have a vending machine implemented onto this FPGA and breadboard with physical inputs and outputs. The objective of this program is to utilize a state machine to accept inputs of either nickels, dimes, or quarters, and vend a drink which costs 35 cents. When our drink or snack has been vended, this output will turn on. If we have change to be collected, this output will turn on, and we will have a nickel be represented here for change. A first dime would be represented here for 10 cents of change, and a second dime would be represented here in the event that we have 20 cents of change. So I'll start by simply inputting a nickel, and I will cycle the clock 7 times to represent 7 nickels going into the vending machine. 1, 2, 3, 4, 5, 6, 7. Here we have dispensed the drink, but we have no change, so none of these outputs show. One more clock cycle will clear these outputs. For some cases, we might receive more than 35 cents, which is the price of the snack or drink we are vending. For example, perhaps we have a quarter which will go in, so we've cycled a quarter in there, and maybe we have a nickel and then another quarter. Here, as you can see, we've dispensed our drink. We do have change, and we have a dime, but one might think 55 minus 35 equals 20, not 10, so we should have 2 dimes here. Well, since a vending machine in real life would output 2 dimes, we must output them sequentially, and after a second clock cycle, we do output a second dime, and then after that clock cycle, we return to state 0. Likewise, we may have something like 4 dimes. 1, 2, 3, 4 dimes. In this case, that's 40 cents. We dispense our drink. We have change present, and this output represents a nickel. So we have 5 cents of change.